Hi, I'm an old guy and I do maths. Today we're trying to find the point of inflection and the x and y intercepts of this cubic. Now it's written in a particular form, and those of you who are familiar with quadratics would recognize this type of equation. It looks vaguely like turning point form. Well, we don't have that with cubics, but we have something like it. And we can use the same principles that we use when interpreting the turning point form of a quadratic equation to go to work on this. Now, let's just have a look at what's going on here. Here we have a dilation factor of some description, plus this is negative, which means that instead of occupying these areas on the Cartesian plane, this is going to occupy these two areas, quadrant 2 and quadrant 4. This form of notation here indicates to us that there is a movement of this graph 1 unit in the negative direction of the x-axis, and this 1 unit in the direction of the y-axis. So if we were to start here at the origin and just assume that this equation was something like x cubed, really simple, when we look at these various alterations to it, what we discover is that the point of inflection, which would be here if this were x cubed, has been moved 1 to the left and up 1. So we have found our point of inflection here. Now, we have a dilation factor of 2, and it's negative, and as I said, therefore this thing looks roughly like that. What we need to do now is we need to find the x and y intercepts. So let's go to work. What is the y-intercept? Well, if we make x equals 0, we can find the y-intercept. So if x equals 0, this is 1. 1 to the power of 3 is 1 times negative 2. So 1 times negative 2 is negative 2 plus 1. Negative 2 plus 1 is negative 1. So what have we got so far? Well, we've got negative 1, 1 as a point of inflection. We have a y-intercept of 0, negative 1. And our next job is to find the x-intercept. And this is where we have a little more work on our hands. So what we're going to do is we're going to make negative 2 x plus 1 all cubed plus 1 equals 0, which is the same. It has the same effect of calling this 0. So where y is 0, we're going to get an x-intercept. Now, it's fairly obvious, I hope, that it's in here somewhere. So it's going to be somewhere between 0 and negative 1. So let's see what we get. Okay, negative 2 x plus 1 cubed equals negative 1. X plus 1 cubed equals negative 1 divided by negative 2, which is a half. What we're going to do now to get rid of this is we're going to take the third root of each side. So x plus 1, the third root of this, is equal to the third root of 1/2. Now I hope all of that makes sense. Now x will therefore equal the third root of 1/2, which is certainly a fairly small number, minus 1. And this point here is going to be our x-intercept. So when we draw this thing, we get something like this. And this, remember, our point of inflection. Remember our point of inflection? It was here. So this is badly drawn on my part, but I'm doing my best. I'm no artist. And this point here is, we'll say -1 plus the third root of 1/2, 0. That's that point. Now, there's one other thing to do, and that is we've already taken account of the negative here, but what we really should do is show that we understand the effect of this dilation of 2 here. So what I'm going to do is I'm going to put another number into this equation and just find another point somewhere on here to demonstrate that we understand the dilation. So what am I going to pick? I'll pick 1. So that gives us -2, 1 plus 1 cubed plus 1. And so that is 1 and 1 is 2. 2 cubed is 8 times -2 is -16 plus 1 equals 15. Sorry, -15. And so we have a point here, 1, -15. And that just shows a teacher or an examiner that you understand the idea of the dilation. So that is it. I'm sorry for the poor artwork, but just to reiterate, what we did was we started at the origin and we put ourselves through these various translations, and we found our point of inflection, which is up here, even if my drawing doesn't show it terribly well. And then we set about finding the y-intercept, which is relatively easy. Make that equal 0. Make that thing there equal 0. Finding the x-intercept is a little more complicated. That's this work here. And then finally, just placing a value into the equation so that someone could see that we understood what the dilation involved. So that is it. Thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.